previous video on stoichiometry, we were always asking about the mass of the reagents and how much products we could make, or vice versa. But we can use other quantities besides just mass. And this is an example where we're using solutions. So rather than telling us about the mass of the substances, they're telling us about the concentrations and the volumes. But I know that I can use the molarity equation to go from concentration and volume to moles, and so I can use these quantities in stoichiometry just like I would masses, or at least similar to how I would use masses, right? And whenever we're doing stoichiometry, we're always going through moles as the intermediate. I think you're going to find in the next chapter, we're going to introduce gases and the ideal gas law, and we can use the ideal gas law to calculate the moles of a particular substance, and so we can do stoichiometry with gases and the ideal gas law as well. Now in this case, they're asking about the volume of lithium hydroxide. So we want to know the volume of lithium hydroxide. And the thing that we're given the information about is we're told the volume and the concentration of sulfuric acid. So I've got 357 milliliters of sulfuric acid. So I've got to get that into moles. And so when I have solutions, the way I go from volume to moles is using the molarity equation. To get to moles of lithium hydroxide, I'm going to use the stoichiometric coefficients, and they were nice enough to balance the equation for us. So I know that 1 mole of sulfuric acid will react with 2 moles of lithium hydroxide. So that'll get me moles of lithium hydroxide. They want the volume, so I'm going to use the molarity equation again. Now, you could set this up like conversion factors, like we did with the masses. I don't generally prefer to do that. I don't usually use the molarity equation like a conversion factor, although you certainly could use the molarity as a conversion factor. I'm just going to do it slightly differently. So I'm going to just kind of treat this as 3 separate problems. I'm going to go from 357 milliliters of sulfuric acid to moles using the molarity equation. Then I'll use my stoichiometric coefficients to get the moles of lithium hydroxide, and then I'll do another molarity problem. So to get the moles of sulfuric acid, I'm going to use M is N over V. Of course, we have to be careful. I want the moles, so I want N. So to get N by itself, I'll multiply both sides by V. So the moles is the molarity times the volume. But remember, when we do molarity, we need to be working in liters, not milliliters. So if you want, you can write out the conversion, although I think it is probably good to start getting to the point where you can do the conversion between milliliters and liters in your head, because we're going to use it so much. There are 1,000 milliliters in a liter, so 357 divided by 1,000, that is 0.357 liters. Right, so the moles of sulfuric acid, back over here on the right, I have 0.250 is the moles per liter times 0.357 liters. And so the moles of sulfuric acid, I get 0.0893. Right, so now I'm at this point in my calculation. So now I need to get to the moles of lithium hydroxide. So I'm going to use the stoichiometric coefficients. So I'll take my moles of sulfuric acid. I know that 1 mole of sulfuric acid will react with 2 moles of lithium hydroxide. And I get 0.179 moles of lithium hydroxide. So now I'm here in my diagram. They want to know the volume of lithium hydroxide, so I'm going to use the molarity equation one more time. Now in this case, I'm solving for volume, so I need to get V out of the denominator. Now I can divide by the molarity. So the volume is the moles divided by the molarity. So I'll take my 0.179 moles of lithium hydroxide, divide that by the concentration of lithium hydroxide, the 0.1 molar, so I'm going to need 1.79 liters of lithium hydroxide.